Okay, hi guys. So let's get started with this lecture. So let's see sign convention. So this is recognized by IUPAC. These are particular the sign conventions for the thermodynamics. Means as in when we'll be taking the positive sign, when we'll be taking the negative sign for W, Q, and other quantities. So this is also recognized by IUPAC. Okay. So suppose we have a system and we are providing heat into the system. Okay, so we can write that heat absorbed by the system would be positive. Okay, so suppose heat absorbed by the system is 20 joule. So we can write Q would be equals to plus 20 joule. Okay, and if we say that heat released by system is 30 joule, then we can write Q would be equals to minus 30 joule. Third, if we write that work done on the system is 60 joule, so W in this case would be minus 60 joule as work is done on the system. And if work is done by the system, then let's suppose work done by the system is 70 joule, then we can write that W would be equals to minus 70 joule. Oh, by the way, this is plus 60. Work is done on the system. Okay. So work done on the system would be positive and work done by the system would be negative. So let's see this further. So suppose what do we mean by work is done on the system? So work is done by the surrounding on the system. By the surrounding on the system. Or in plain words we can write that work is done on the system, just like the previous statement. So work done on the system, this would be always considered as positive. Why? If you look at P would be equals to minus P del V. So work is done on the system, hence this was our system and work was done so as to compress it. Okay, so when we are compressing it, V final would be less than V initial, hence Vf minus Vi would be negative, hence V would be, or rather W would be positive. Okay, so this was just an explanation, just erasing it again. Okay, so we can write example is gas compression as we just saw it. Okay, next work done on the system, so we'll be taking this point, or rather work done on the system is already taken care, we'll be looking at work done by the system. So what will be this work done by the system? So work done by the system would be on the surroundings. So work done by the system on surroundings. Okay, so this would be negative and example would be gas expansion. So suppose again the system is doing some work on the surrounding, so as a result it would be expanding, so Vf would be greater than Vi, and as we know that W is minus P into delta V, hence delta V would be positive, hence W would be negative. Okay, now let's see dq. So dq is mc dt. M is mass, C is specific heat, and the unit of the same would be, let's say, joule per gram Kelvin, and T is the dt is dt or T in dt is temperature. Okay, so we can also write dq as C dt, where C is heat capacity. Heat capacity which would be measured in terms of joule per Kelvin. Okay, so again C can have two forms, which is Cp and Cv. Cp is heat capacity at, this is heat capacity, oops, so this is heat capacity, and if we are writing C in subscript, we are writing P, so this is heat capacity at constant pressure, and Cv is heat capacity at constant volume. Similarly, if we talk about Cm, so Cm is molar heat capacity, and molar heat capacity again can be subcategorized into two parts, which is Cpm and Cvm. So Cpm is molar heat capacity at constant pressure, and Cvm is molar heat capacity at constant volume. Okay, and unit of this is again joule per Kelvin, and for Cm it is joule per mole Kelvin. Okay, so let's say for an ideal gas we can write that, let's say for n moles of an ideal gas, we can write that Cp minus Cv is equals to Nr. So Cp divided by N minus Cv divided by N is equals to R. So this implies Cpm minus Cvm would always be equals to R. Please remember this. This is a very important formula. Okay. So we can write that for solids, liquids or gases at constant volume, we can say that du is equals to dq plus dw. So we are writing constant volume, so dw would be 0. So this is also an example of isochoric process. Okay, so we can just write that du would be equals to dq, so we can write delta U would be equals to QV, means heat released or absorbed at constant volume. Okay, and in isochoric process we know that dV equals 0. As dV equals to 0, dW would also be 0. Okay, so with this we before ending the lecture, let me write some notes here, that heat absorbed by the gas relating to this is du, delta U rather. So delta U would actually mean whatever heat is absorbed or released at constant volume would be equals to delta U. And now the note says that heat absorbed by the system in constant volume would be equals to increase in internal energy of the system. Heat absorbed by the gas in constant volume would be equals to increase in internal energy of system. And similarly we can write that heat released by the gas in constant volume would be equals to decrease in internal energy of the system. Gas in constant volume would be equals to decrease in internal energy of the system. Okay, so with this we come to the end of this lecture. We'll meet in the next lecture. So till then, good luck and goodbye.